Hi, Middle 3. In the last session, we was talking about the Cartesian product. And we knew that the Cartesian product is the crossing points or the crossing area between two sets. Today, we will talk about something called relation. And it's so connected with the Cartesian product. It's mainly depend on the concept of Cartesian product. How? Let us see. Relation. We will explain relation through this following example. If we have a set of 4 persons, this set called X, and this set contained Ahmed, Ali, Majid, and Said. And they all went to fruit shop. And this fruit shop offers 3 kinds of fruits: apple, orange, and grapes. And I will represent these 3 kinds of fruits in a set called Y. So now I have 2 sets, X and Y. X has 4 names of people. Y has 3 kinds of fruits. Now, if Ahmed bought apple and orange, Ali bought only grapes, Majid bought apples, and Said didn't buy any fruits. This is a situation. So we can say that the word bought has connected some elements of X with some elements of Y. Before the buying process, there is no connection between X and Y. What make a connection between X and Y? The buying process itself. When some elements or some people belong to X bought some fruits belong to Y, so I had connected X with Y. So the buying process or the word bought has connected some elements of the set X with some elements of the set Y. So there is a relation between X and Y, or I can say that there is a relation formed from X to Y, not from Y to X, because Ahmed bought apple. Okay, Ali bought grapes. So the relation formed from X to Y, and we denoted this relation by symbol R. So till now, from this example, I only have a relation between 2 sets from the buying process. Okay. So the situation now is that Ahmed bought apples and orange, Ali bought grapes, Majid bought apples, and Said didn't buy any fruits. Okay, how can I represent this relation graphically? If I have the first set X, which contained Ahmed, Ali, Majid, and Said, and the second set which contained the 3 kinds of fruits, which is apple, orange, and grapes, like 2 sets, like the Cartesian product of 2 sets. Okay, but in the Cartesian product itself is all the ordered pairs I can have from crossing of the two sets. Here in relation, I don't want to illustrate all the possible ordered pairs. I only want to illustrate what happened in the relation, what happened in the buying process. So I only have Ahmed bought apple and orange. Ali bought grapes. Magid bought apple and Said didn't buy anything. So this is the arrow diagram of the relation, not the arrow diagram of the Cartesian product. So again, let's pointing the difference between the Cartesian product and the arrow diagram of a relation. The arrow diagram of the Cartesian product means that every element in X connected with every element in Y. And I will illustrate all the ordered pairs coming out from this crossing. In the relation, I only illustrate the relation between X and Y. Here Ahmed bought apple and orange. He didn't bought grapes. So there is no arrow from Ahmed to grab. Okay? Ali buy grapes. He didn't buy apple or orange. So there is no ordered pair called Ali apple or Ali orange. Okay? I think it's crystal. And that's, as we said, called arrow diagram. And we can also represent it by Cartesian diagram by putting X in the horizontal axis and Y in the vertical axis and begin to find the crossing point of this relation. So Ahmed bought apple and orange, only he didn't buy grapes, so there is no point in Ahmed grape. Ali bought grape, Magid bought apple, and Said didn't buy anything, so there is no intersection point in Said column, and that's called Cartesian diagram. And if we want to write the ordered pair of this relation, I will say that R equals to set contains what? Contains Ahmed apple, Ahmed orange, Ali grapes, Magid apple. That's all. That's all. Again, there is a big difference between the relation and the Cartesian product. The Cartesian product about telling all the possible points in the Cartesian diagram. The relation is about what process I am talking about. The boat. Here the boat, the buying process. Ahmed just bought orange and apple. He didn't bought grape. So the ordered pair Ahmed grapes didn't exist. Okay. Now we have some notes. Like what? The relation R is a subset of the Cartesian product X crossing Y. And that's crystal. Okay, because I choose some ordered pair from the Cartesian product which satisfy the relation. If ordered pair AB belong to the relation R, we can write that expression as A or B, and that's mean there is a relation between A and B. A is a set and B is a set, or there is a relation formed from A to B. A is the first set crossing B as a second set, and we have some condition, and that's called relation, and it's called A or B. Third note, if the ordered pair AB belong to R and R is a relation from X to Y, then A belong to X and B belong to Y. And that what we have learned from the Cartesian product. The ordered pair comes out from the Cartesian product or a relation. The first projection belong to the first set and the second projection in the ordered pair belong to the second set. The last note, if R is a relation from X to X, so I'm talking about a subset of the Cartesian product X crossing X. Then I can say that then R is a relation on X. Relation on X. Now let's have some example to understand the relation. If X equals 1, 2, and 3, Y equals 1, 2, 3, 4, 5, and 6, and R is a relation from X to Y. When I see that R is a relation from X to Y, so I'm talking about R is a subset from the Cartesian product X crossing Y. The order is so important. Where A or B, that means the relation from X to Y, means A, which belongs to X, is a factor of B. For every A belong to X and B belong to Y. He wants me to state the relation. It means to write the set of the relation and represent it by Cartesian diagram. Okay. Now I want to make some ordered pairs. These ordered pairs have two numbers, A and B. A belong to X and B belong to Y. If I take every A to every B and Y, so I will have the Cartesian product. I'm not searching for the Cartesian product. I'm searching for a relation. So what is the condition? The condition is A is a factor of B. It means that the first number must be a factor of the second number. So I will take every element in X and search what number in Y satisfy this condition, which is A is a factor of B. So I will set that the ordered pair 1 and 1 satisfy the relation. Also 1 and 2, 1 and 3, 1 and 4, 1 and 5, 1 and 6, because 1 is a factor of any number. When I take 2, which belong to X, so I will take 2 and 2, 2 and 4, 2 and 6. Then 3 and 3, 3 and 6. And that's what I called stating the relation R. Okay? If I want to check all the ordered pairs, I will check the condition. In every ordered pair, is A is a factor of B? Yes. 1 is a factor of 5. 2 is a factor of 4. And 2 is a factor of 6. 3 is a factor of 6. And so on. Okay? Now I want to represent it by Cartesian diagram. So I will have two axes. The horizontal will be X and the vertical will be Y. So we will draw X in the horizontal axis as the relation is formed from X to Y. So X crossing Y. So X will be the first set. It will be in the horizontal axis. And Y will be in the vertical axis. And then we will crossing all lines from X to Y and then determine the relation like that. 1 and 1, 1 and 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 2, 2, 4, 2, 6, 3, 3, and 3, 6. And from the Cartesian product, we can understand the main difference between the relation and the Cartesian product. The relation is about pointing some points, not all points. All points means Cartesian product. Some points means relation. And these points, every point of these red points satisfy the relation A is a factor of B. Another example. In the opposite arrow diagram, this is an arrow diagram, and this arrow diagram represents the relation R on X. And when I see relation R on X, that means it comes from the Cartesian product of X crossing X, or X crossing itself. He wants me to state R, then represented by Cartesian diagram. So I will state R first. How to state R? I will set that R and R equals 2, and I will go to every arrow. So I will have AC, AD, EA, DD, DA, BB, and BC. And to represent it on the Cartesian diagram, I will have two sets, X and X. One of them horizontal line, the other on the vertical line, like that. Then I will construct all possible pairs, like that. Then I will pointing the ordered pairs which belong to the relation, which is AC, AD, EA, DD, DA, BB, and BC. Now we have another concept called function. Now we have three concepts. Cartesian product, and it means all possible ordered pairs comes from crossing two sets together. And we have concept of relation, which is subset of the Cartesian product, and it means I want to pick some ordered pairs from the Cartesian product that satisfying a certain condition. And the last concept we have is function. What is function? And to know what function is, let's discuss this example. If we have a set called X, contained 0, 1, 2, 3, and Y contained 0, 1, 2, 3, 4, 5, and 6, and R is a relation from X to Y, where A or B means A is half B. A equals half B for every A belong to X and B belong to Y. So if I want to illustrate this relation, so I want to form some ordered pairs under the condition of the first projection equals half the second projection. Okay, so I will have R equals 0, 0, 1, 2, 2, 4, 3, 6. That's the all ordered pairs satisfy the relation A equals half B. And I will illustrate it by arrow diagram like that. X is a first set and Y is the second one, and we'll have 0, 0, 1, 2, 2, 4, 3, 6. This is arrow diagram, and by Cartesian product we'll have X and Y like that. Then I will determine the ordered pair of that relation, which will be like that. This is Cartesian diagram. So for this example, till now it's ordinary, like the examples of the relation I have studied in the last section. So what is function? What is the new? In this example, I will note some things. Something like what? Every element in X has been connected with one and only one element in Y. This relation is called function or mapping. So the function is a relation, though function is a relation, but it has one option or one condition, that every element in X, every element in the first set has been connected with one and only one. So I have two conditions. Every element in X has been connected. Every element in X has been connected once with element in Y. One and only one. So if an element of X connected twice with two elements, so it's not a function, it's only a relation. Understood? And now, the set of X is called the domain of the function. This set, the first set, is called the domain of the function. The set Y, which is the second set, is called the codomain of the function. And we have a relation between X and Y here. And we will note that it's really every element of X has connected once and only one with an element of Y. Okay? This element of Y, which is 0, 2, 4, and 6. These four elements is called range of the function. So the range is a set 0, 2, 4, and 6. And it's called the range of the function. So now for the function I have three names. I have the first set called domain, the second set called codomain, and the second projection in every ordered pair in the function is called the range. And it's a subset of the codomain of the function. The range is a subset of the codomain of the function because 0, 2, 4, 6 belong to Y, which is the codomain of. Okay. Example. If x equals 1, 2, 3, 4 and y equals 1, 3, 5, 7, show which of the following relation represents a function from x to y. And if it is a function, mention the range. So I will check every relation of these three relations and want to show if it's a function or not. So to judge on the relation if it was a function or not, I have two conditions. Every element in x must appear once and only once. Every element of x must appear once as a first projection. So when I look to R1, the first relation, which have some ordered pair like 2, 3, 1, 1, 3, 5, 3, 7, 4, 3. I will note that 3 appears twice. So 3, the element 3 in x, appears twice, connected twice. First time with 5, second time with 7. So it's not a relation. So R1 is not, it's not a function. So R1 is not a function because the element 3 appears 2 times or twice in the relation. What about R2? R2 contained 1, 7, 2, 5, 4, 3. R2 doesn't have an ordered pair, its first projection 3. So when I said that every element in x connected once, so the word every doesn't exist here because 3 doesn't exist as a first projection. So R2 also is not a function because the element 3 doesn't appear in the relation. What about the third relation? 2, 3, 3, 3, 1, 5, 4, 7. Definitely it's a function because every element in x appears one and only once as a first projection in the ordered pair of the relation, so it is a function. Yes, it's a function because all element of x appears once as a first projection in the ordered pair of the relation. And the range is, we deal that the range is the set of the second projection of the ordered pair of the function. So it will be the range equals to 3, 5, and 7. I think it's so easy. Another example. If x equals 0, 1, 2, 3 and y equals 2, 3, 4, 5, 6 and r is a relation from x to y and a or b relation from x to y means a plus b equals 5. So I want the two ordered pairs, their sum equals 5, like 0, 5, 1, 4, 2, 3, and so on. For each a belong to x and b belong to y, write the relation R. First, I want to write the relation and represented by arrow diagram. Then mention giving the reason if R is a function from x to y or not, and if it's a function, find its range. First, I will illustrate the relation. I want that the sum of the two numbers in the ordered pair equals to 5. This is the condition. So I will set that R will be 0, 5, 1, 4, 2, 3, 3, 2. This is R. And I will represent it by arrow diagram like that. I will draw x and y and then make my arrows 0, 5, 1, 4, 2, 3, 3, 2. Okay. Now I want to check if this relation is a function or not. To check that, I have my two conditions. Every element in X appears once as a first projection. Is that okay? Yes. Yes, every element in X, 0, 1, 2, 3, appears once as a first projection. So R is a function? Yes, because all element of X appears once as a first projection in the ordered pair of the relation. And the range is the second, yes, the second projection of the ordered pair, which is 5, 4, 2, and 3. That's what relation means and function means. I wish this lesson is easy enough. I want you to solve more and more problems in the school book and in your booklets. And I will send you the paper numbers which I want you to solve. Thank you, middle 3. I wish you lucky days.